Okay, the purpose of this video segment is to show you a feature in 3D Experience's finite element package that is called compare results. Okay, this is done for post-processing purposes. That is the icon, and in order to be able to use that, you must have run the analysis and be in the results part of the program. And there we are. So we are here. These are the post-processing icons and the tabs. And you click on the display. And when you in the display, you will find the compare results icon. Now let me show you what it does. Okay, so at the end, I want to get two set of results side by side of an analysis that I have done. Okay, for example, the one on the left corresponds to a block which is restrained and loaded somehow, and the one on the right is the same block except that there are fillets at the two ends. Okay, I want to be able to put these things side by side so that I can compare what the effect is. Now, the procedure that I'm going to show you is not, very effective because I end up changing my original part. Uh, this is best done in terms of creating abstraction of the part so that you don't mess up the part. Okay, so that's not the focus of this video tutorial. So I'm going to show you this process. Although it shows you how it works, I'm not suggesting that the way I'm doing it is either the best or the only way of doing it. So in the context of the example that we're going to do, we have a block here, which is 10 by 5 by 1, and one end of it is clamped, and this top face is subjected to a pressure of 100 psi. It's a very simple block because I want to show you how the process works for comparing results. Not to mask the problem and convolute it so that you get lost in the other aspects which are irrelevant to the present tutorial. So we're going to try this thing without the fillet and then again run it with the fillet. We put two fillets here. That means that the way I'm going to do it, I'm going to destroy my part. Whereas if you do abstraction, that doesn't happen. You keep your original part, you create an abstraction of it and run analysis on it. But that's not what I'm doing. Okay, so let's go ahead and do this. All right. Uh, I'm in part design, so on a convenient plane, on that plane, I will sketch a rectangle which is 1 inch by 5. So that's going to be 1 inch, and this is going to be 5. Okay, and then exit and pad it by 10 inches. So there is my part. And let's apply material to it. So standard steel properties. So we go to tools, create a material, compare results, compare results video. Okay, and notice that the simulation domain is checked, which is good. Okay, it's going to be created, but of course it's a blank holder now. I did not put anything in it. So let's actually refresh this. Compare results video, right click, apply. We can close that. And we apply it to our part. Now we're going to go and add the material data in it. So it's going to be structures, abacus multiphysics, mechanical, elasticity, elastic, and this is 30 million psi. 30, 1, 2, 3, 4, 5, 6, and Poisson ratio 0.3. All right. Okay, so the first run that I'm going to make is actually not putting any fillets here. So we're going to go to the meshing stage, which is structural model creation standard. I'm going to use a sweep mesh. Okay, so let me see how this is going to turn out. So the size of the element 20.25 and 4 layers. I don't think this is what I want, but we're going to see that. Oh, actually, it's all right. 4 layers this way. Yeah, that's good. That's good. Now, why don't I save this thing? Okay. And now we're going to go to structural scenario creation. We're going to use the finite element model that we created right there, that mesh basically. All right. If you ever lose the tree, just press F3, it's going to come back. Okay. So we're going to go to procedure, static. It really doesn't matter. I can solve this thing as a linear or nonlinear problem, so just leave it the way it is. That's okay. Nonlinear is fine. That's totally irrelevant to the present video. Okay, so we're going to go to the restraints, clamp the end on this side. Okay, and apply a pressure load up there. So on the load, we apply pressure on that top face, and we put 100 psi. 100 psi. Okay, so that takes care of my model and the finite element discretization of it. Now we're going to run it. So we go to simulate. I'm not going to bother doing these. These are the data check and basically the model check and scenario check. This is a simple problem. Nothing can go wrong with it. So I'm just going to run and simulate it. I strongly advise that in complicated problem that you're not sure whether it's going to work or not, or whether you have made a mistake or not, just do this thing first. Now, notice that there is a box here which says overwrite previous. Now we don't have a previous. This is what we started with. Okay, so we're just going to run it. We're going to worry about that after we modify the part and run it. We're going to worry about that. Right now it was dimmed anyway. There's no previous. That's going to be quick. It's a very simple problem. Yeah. Extracting results. That's good. Okay, it's done. So we're going to say OK or close. All right, so you can see that this is the von Mises stress. Move this thing closer. That is the von Mises stress. Something strange here because this is too low. I'm not sure whether I actually inputted my material properties correctly or not. Let's check it out. Let's check. PSI, Poisson ratio, that's okay. I'm surprised the values are so low. So where is this thing right there? let me check the load. Oh, PSI, not Pascal, PSI. That bothered me because it was so low that it just didn't make sense. So I'm going to run it again. Sorry. This is a piece of steel and there's a load which is not that big here. Now, overwrite the previous result because the first time I made a mistake. As simple as that, okay? I did make a mistake, so I'm going to overwrite that, okay? This is a piece of steel loaded with 100, you know, PSI, which means 1,000 pounds. It's not. It's going to have some stress in it, but not very much. But not as low as what I had because I had 100 Pascal. 100 Pascal is nothing. The atmospheric pressure is 100 kilopascal. Okay, it's probably of the order of, I don't know, thousands of PSI. Okay, yeah, 1700. Very good. Okay, now, so this is done. What I want to do now is to go and put a fillet here. Okay, so let's go to our part, which was here, our part, to that path. Okay, and we're going to put a fillet there. Now, what that means, the way I'm doing it, because of changing my part here, obviously my original part is modified. As I said, abstraction is creating abstraction of the original part is a better way of doing it, but that's what we're going to do. So where is the fillet? Right there. So I want it at that face, at that edge, and the bottom edge, and 1 inch fillet. Uh, Preview looks like this, and we say okay. All right. Now, if we go back to the model that we created, the final model, uh, and if you look at your, obviously I've modified the geometry. So if I double click, for example, if I double click on the nodes and elements, there are different ways of doing this thing. And if I say update, there are other ways of doing this thing. The point is that I don't want to do too much work, so there we are. Okay, everything is the same. Okay, so we're going to run it again. So we go to scenario. Okay, and run it. Just be careful here because this is where you're going to say, hey, do not overwrite my, see that? Do not overwrite my previous results. So overwrite previous? No, keep previous. In other words, the analysis that I made without the fillet, I want to keep it because ours was side by side. And then you're going to say, okay. What I'm showing you also includes generating graphs and things like that. You can do that, but I'm not worried about it at this point. I'm just showing you, you know, when I say graph is history graphs and stuff like that. But I'm not doing that. Good. So let me close this. So you can see that this is the result when there is a fillet. Now the other thing is that notice that here, if you look at this plot, you have current and previous. If I go to previous, it shows me what I did originally and did not overwrite it. Write it. Okay. So if you go to current, you're going to see the von Mises stress for the one with the fillet. Okay. Now, before I do anything Let me save this. Okay. So remember I said go to the display tab right there. You are in results. Go to the display tab and select that icon. So here's the display tab. Here's the icon that I was talking about. You click on it. This pops up. And notice what it says is that, look, first of all, you are doing the, let's see now, be careful here because if I see what I've got, uh, oh yeah, results of the structure analysis. See, there's two of them here. One is the one that I just created, and the other one is the previous one, okay? So if you go to this is the current one, already uh, there is a one Mises stress already on the screen. It's this, okay? Suppose I want to put the displacement also next to it. So I grab this, see that? Grab this, put it there, okay? Okay, one of them is going to be the one Mises, the other one is going to be the displacement next to it. Now, we're going to go to the previous one, okay? And the one Mises, I'm going to select it like that, left mouse button selected, drop it here, and the displacement selected, and drop it in here, okay? And then you say, okay, there we are. So this was the one that I did originally, one Mises displacement that I selected and dropped it in those boxes. And this is the one that I modified. Now, let me show you what this, there's a dialog box here. There's a box here which says, what do you want, to do? So do I want to save this so that if I came tomorrow, this is going to be accessible to me? So I say, yeah, save as. So I'll say my first comparison one. Okay, how about calling comparison one? Say okay, save. All right. And all right, close it. Notice that at the bottom of the tree, this has been created. Comparison one has been created. So if I double click on this, there we are. Okay. Now, let me show you something else here. Say close. Let me create another comparison. Okay. For example, let's go here and click on this thing again. For example, let's say that you want to put the deformed and undeformed shape of the original and the current and the displacement. As a matter of fact, you can split these into more graphs. For example, if you look at this, I can do a vertical split. See that? And down here also we can do a vertical split. Oh, actually, let me do the vertical split up there. Yep. Okay, this was vertical split, this was horizontal. Let's put some stuff here. So, for example, deformation. I'm going to put it there. Undeformed model, I'm going to put it there. Now we go to the other model, previous one. Deformation, I'm going to put it here. Undeformed, I'm going to put it there. And one Mises, I'm going to put it right there. And we say, okay. You see? By the way, you can rotate these things. You can move things around, zoom in, zoom out, zoom in, zoom out, zoom out. You can move these legends around. You select it, you move it, just like you do in ordinarily in the 3D experience context. So you select this thing, move it, and save as. Call it comparison two or whatever name that you want to give it. Say okay, save, and we close this. Notice that at the bottom you have these two. Okay, so even if I close this, Okay, so let me save everything first. Even if I close this physics simulation right there and close that and came back tomorrow and wanted to look at this, I go to my content. Let's see if I can find this thing. I think it was this, if I'm not mistaken. I'm not sure. I should have given it a name. Open. I should have given it a name that could have been recognized. Okay, good, good. Notice that these things are still here. For example, if I double click on comparison one, okay, uh, you click on this, compare results. It says here, over here, you say saved comparisons. You already saved. See, I clicked on this icon which says compare result. This thing popped up. You can make new ones if you want. Excuse me, or you can go to the one that you already saved. Comparison to. Remember, I split the screen into several pieces right there. Close. So this is very useful. You can take two set of results and put the stuff side by side, customize it as you wish. You can also have the history plot and things of that kind. But as I said, the way I did this was that I actually modified my original part, which was not a good strategy. Uh, the better strategy is before you run the analysis every time you run it using an abstraction shape. In other words, you take your original model, you create an abstraction of it, and then you can change the abstraction, put fillets in there, remove fillets, etc., and without destroying the original part. And incidentally, if you change the original part, the abstraction will also change. Okay, I hope that you found this thing useful.